Hey everyone, it's Danielle from Mastering Mathematics, and in today's tutorial, we're going to be looking at a past paper problem where we are going to be using a trigonometric ratio. This particular past paper problem is taken from the General Proficiency Paper 2. We're looking at the May-June 2004 question, and we're looking at 4B. Now, in this particular question, you'll notice that we have a rectangle, EFGH, but if you look within the rectangle, you'll notice that it's subdivided into three parts. Now, let's take a look at the information that they've provided for us in the diagram below, not drawn to scale. EFGH is a rectangle. The point D on HG is such that ED is equal to DG, which is equal to 12 centimeters. And GDF, this is a typographical error I made. I'm a human being. But the angle's magnitude should be 43 degrees, which I do have on the diagram. Alright, so the information is labeled appropriately on this diagram. And we're going to be using the information we're provided with to calculate the length of the side GF. And they want it correct to one decimal place. Let's see how many of us were able to get the correct answer of 11.2 centimeters. We're going to start off by looking at the problem. Now, as I mentioned before, it's a rectangle. You might think, how am I going to apply a trigonometric ratio or any bit of trigonometry in here? But if we look closely, we can see the three triangles, and one that we're interested in is one labeled DFG, because this is where the length GF is. In here, the information we're presented with the length of DG. We see this length is 12 centimeters. Alright, now if we look again, we notice that we have the magnitude of one of the angles, right? That's the angle GDF, labeled 43 degrees. If I want to find the length of GF, in this case, I need to know whether or not I can apply a trigonometric ratio. Now, luckily for us, they said it is a rectangle. So if this is a rectangle, can you recall any properties of rectangles which would help us clarify and validate the use of a trigonometric ratio here? Can you think of one property that's going to help us at least establish that this is a right-angled triangle formed over here, DGF? First of all, we should be able to recall that a rectangle consists of four right angles. And we can see that a right angle forms. Now, if we have a right angle at DGF, we have ourselves a right angle triangle, and this means we can use our trigonometric ratios. Which ratio should we use? We know for a fact anytime we're doing trigonometric problems, the first thing we should do is identify the ratio we're going to use. Now that we know that there's a right angle triangle formed here, we are going to use a trigonometric ratio. Now we always have to decide which ratio we're going to use. If we want to find the length of GF and we're given the length of DG, can you think of which ratio we're going to apply, or at least you know how to determine which one we're going to use? So we have the magnitude of the angle GDF, and this angle is next to the length DG. So what would we call this length? That's right, we'll call DG the adjacent. Since the length DG is next to the angle that we're given, this is our adjacent side. Okay, GF, which side is this? It's facing the angle we're given, so this means that GF is our opposite side. That's right. Let's label this the opposite side. Okay, so now I know that if I want to use a trigonometric ratio, I must use the ratio relating the opposite and the adjacent side. Which ratio is that? That's right, our last video we learned about the tan ratio. So we're going to use the tan ratio here. And we begin. Let's theta ratio. So tan theta. Alright, let's replace it with the notation. So we'll apply it to this problem. From here, what should we do? We should substitute the values we know. That's right. If I want to solve for GF, I need to make GF the subject. So this means I need to transpose. And that means we need to get rid of this denominator. So let's multiply both sides of the equation by 12, right? Both sides of the equation multiplied by 12. This gives me 12 tan 43 in my next line. All right, and for the right hand side, those 12s cancel off, leaving me with GF. That's correct. Okay, now if I want to solve for GF, all I have to do at this point, plug in this statement into my calculator and evaluate it. All right, now keep in mind they said they want the answer correct to 1 decimal place. So let's just plug in this statement exactly as it is, and then we'll do our approximation afterwards. All right, so let's go to our calculators. All right, so on my calculator, I'm going to type in 12 multiplied by my trig ratio tan. I'm going to enter the magnitude of my angle. That's equal. All right. So did you get 11.19? If I want to round this up to 1 decimal place, I'm looking at this position here, and this means to round this off, we'll get 11.2. All right, and that's our answer. The length of GF is 11.2 centimeters. All right, units are important. And that's how we do this. Alright, so this is how we apply our tan ratio to find the length of a missing side. If you understood this tutorial, you managed to get through the solution all on your own or with a little guidance, great job. Now you can apply the tan ratio to absolutely all your problems where you need to find missing sides involving your tan ratio. And I'm sure you'll be able to do it with much ease. Our next bit of trig work will be on using the trig ratios to find the magnitude of a missing angle. If you know how to do this and you just want a refresher, you can tune in. Thank you so much for tuning in, for supporting, and I appreciate the support. If you enjoyed this tutorial, leave a thumbs up, leave us a comment, let us know how has it been for you thus far. You can look forward to more content concerning tricks and other topics right here.